Halo Bang Bu. Halo Bang Bu. Halo Bang Bu. Halo Bang Bu. Halo Bang Bu.
See, we have this that's in between of 0 and 0, so we can come here and conclude that this is equal to 0. So this is just a continuation from the previous video. Here I just want to talk about that when we use the polar coordinates to evaluate the limit of a multivariable function, we have to be extra careful. So this is the one that we did in the previous video. We have the limit as x, y approaching the origin, x to the third power is to x to the fourth power, and then plus. We have the limit as x to the fourth power, and then plus. We have the limit as x.
What is time? A deceptively simple question, yet it is the key to understanding relativity. It is also the reason my hair is going grey. When we describe motion, we do...
Newton's second law of motion. You all know it. But as we delve deeper in Newton's second law of motion. You all know it. But as we delve deeper in Newton's second law of motion. You all know it. But as we delve deeper in Newton's second law of motion. You all know it. But as we delve deeper in Newton's second law of motion.
Katanya anime ini indah banget, tapi ada juga reviewer yang bilang kalau animasi
Bitcoin naik secara signifikan. What's happening in the cycle? Kenapa ini sebenarnya bukan 2021 tapi ini 2019? Run up-nya belum dan run up itu di 2025. Kita selalu bilang super mega cycle itu 2025, tapi kita udah dapat gambar yang lebih clear bahwa konsolidasi lama ini fasenya mirip yang bikin orang nyerah di 2019. Coba share tesisnya bro.
Harga Bitcoin itu mendekati dengan cycle all time high di 2018, nggak berhasil menembus. Ini flagging dalam konsolidasi yang sangat lama.
Bitcoin naik secara
Kamu tuh gaji cuma
Oke, di video kali ini gue akan jelasin ya.
Di video kali ini, gue capek sama orang-orang yang suka komplain ya. Buat kalian para pecundang, di sini gue mau kasih tahu gimana caranya hidup lu tuh bisa jadi hoki. Kalau hidup lu seumur hidup cuma
akan menemani kembali kalian di malam Senin, horor malam Senin.
Since energy can never be created or destroyed, and objects at higher elevations have more energy, this means that objects must speed up as they fall.
What is a mathematical proof? Loosely speaking, it's an argument or a verification of a mathematical fact. That fact is typically called a theorem. And that's usually our goal with math.
Lah, kok Mister?
Menganalisis produk peluruan dan sebagainya. Diketahui, partikel Higgs boson teridentifikasi menggunakan model pendeteksian ini. Ya, dari beberapa partikel teoritis yang hingga saat ini masih terus diburu bukti keberadaannya. Materi gelap adalah buronan nomor wahid bagi para ilmuwan. Berbagai metode telah diupayakan untuk menemukan partikel misterius penyusun 20% keadaan alam semesta ini. Bahkan salah seorang fisikawan Mike Lamont,
penyusun massa, sabar, interaksi dengan massa.
अच्छा देखो,
Yes, I am serious. Today we'll be doing 100 derivatives and we'll be doing them in one take. However, this is not the first time doing this though, because I actually did this 10 years ago already. But let me tell you guys this first. I would like to dedicate this video to all my upper bound students, especially the ones in 2009 in the summer at UC Berkeley campus. And let me tell you guys, my upper bound students, I still remember everyone.
Aduh FM, DJ Halim di sini, siapa di sana?
Halo, Makcik Kiah sini.
Merdunya suara Makcik Kiah.
Nak lagu Lembu dah beli dah belah.
Lembu dah beli dah belah. I rasa
Sabar di testing dulu guys, sabar dulu guys. Alimpat, sabar.
Riemann hypothesis. Let's say you're at a
Sudah sering itu. Beauty of physics.
Let's calculate work done when things are dropped or lifted. Let's solve two problems on this. Here's the first one. A dumbbell of mass 5 kg drops to the ground from a height of 10 meters. Calculate the work done by gravity. We're given g is 10 meters per second square. So let's quickly go ahead and draw the situation. So we have a dumbbell whose mass is 5 kg. It's dropped from a height of 10 meters, so it just falls down. So this dumbbell just falls down from a height of 10 meters. And in doing so, we need to calculate the work done by gravity. Let's first write down what are the given things to us. I know the mass of this dumbbell, so let's write that down. The mass is given to be 5 kilograms. I know the height. The height is given to be 10 meters. And I'm also given the value of G to be 10 meters per second square. From this, how do I calculate work done? Well, we have seen from previous videos that work done by a force on any object equals the force multiplied by the displacement of that object. In our example, the object is the dumbbell. And the force acting on the dumbbell, which we are asked to calculate, is the force of gravity. So in our case, if we multiply the force of gravity on this dumbbell with the displacement of that dumbbell, we'll get the work done. So before we go ahead and do this, great idea to pause the video and see if you can try to get the answer yourself first. All right, let's see. First of all, notice we already know the displacement of the dumbbell.
Kayaknya kan bukan
Right?
mg.
The dumbbell gets
5 kali
displaced by 10 meters,
50 meter
which
per
is just the
second,
height
jadinya
through which it
50
fell
newton.
down. So we know
Dengan
that.
berpindahnya 10
So
meter,
all we need to
jadi
do now is calculate the force.
500
Which force is this?
joule
This is the
kayaknya.
force of gravity. Do we know how to
Work
calculate
done.
force of gravity? Yes, we do. So if I keep my dumbbell somewhere over here as it was falling, then we know the force of gravity on any object is going to be the mass of that object times G. This is the force of gravity. So now that we know both the force and displacement, let's just plug in and see what we get. So force is just the mass times G, and the displacement is just the height. Now, one thing we need to be very careful over here is, remember, work done can be both positive and negative. It's positive when the force and displacement are in the same direction. It's negative if they're in the opposite direction.
Work done
In
adalah
our example,
dot
which one is
produk
it?
dari
Well, notice the
gaya
force
dan
is acting
perpindahan.
downwards, even the displacement is
Dot produk.
downwards. So in our
Ya,
case,
maksimal
the
jika
work done is going to be positive.
ya telah
But
saing
before we continue and plug in,
lurus
just think about what would have happened if I had
sejajar,
thrown the
ya,
dumbbell up.
sejajar.
Now, the force of gravity would still be acting downwards,
Atau-
right? Gravity always acts down. But our object, our dumbbell, would be going upwards
F kali
in the
S cos
opposite
theta
direction.
terhadap
So the displacement would be in the
perpindahan,
opposite
sumbu
direction of the
perpindahannya.
force of gravity. In
Garis
that
perpindahannya
case,
pokoknya.
the work done would be negative. So if you throw this dumbbell up, then gravity will do negative work. But of course, in our case, since the dumbbell is falling down, the gravity is doing positive work. All right, let's just go ahead and substitute the numbers and see what we get. Again, if we had not tried this before, great idea to pause the video and see what answer you get once you substitute. Okay, let's go ahead and plug in. So the work done, let me choose a brighter color. So the work done is going to be mass, which is 5 kilograms, times G, which is 10 meters per second squared. This is our gravitational force, times the height, which is 10 meters. And so the work done becomes 5 times 10 is 50, 50 times 10 is 500. So we get 500. Let's look at the units. Don't forget the units. Kilogram meter per second square. Let's keep that separate. That's the unit of force. That's the unit of force times meters. Now, kilogram meters per second squared, since it's the unit of force, we can also write as newtons. So we'll write this as newtons times meters. And so that's the work done. Work done by gravity is 500 Newton meter.
Itu satuannya, Bang.
But of course, remember, Newton meter is
Satuannya,
also called
guys.
joules. So we can also say 500
Satuannya.
joules. That is the work done by
Joule.
gravitational
Newton
force
meter.
on our dumbbell. It's positive. All right, let's go ahead and solve another one. Here's the question. A woman slowly lowers a 20 kilogram barbell rod through a distance of 0.2 meters as shown below. Find the work done by the woman on the barbell. So she's exercising maybe, and so she takes that barbell rod and she's lowering it. So let's look at that. If you could see it, maybe it looks somewhat like this. She lowers it this way. That's given to us, okay? We need to calculate how much work the woman does on the barbell. So let's see. Let's again write down what's given to us. We know the mass of that barbell rod. So let me write that over here. It's given to be 20 kilogram. We know the distance through which it moves. Let me just call it as the height. That is given to be 0.2 meters. And again, we're given G to be taken as 10 meters per second square. And again, since we are asked to calculate the work done, we'll do it as force times displacement. We know the displacement, that is 0.2 meters. But what's the force? See, here we have to calculate the work done by the woman on the barbell. So this must be the force that the woman is putting on the barbell. How much is that? Well, I guess here's the clue. It's given that the woman is slowly lowering the 20 kilogram barbell. Imagine she's slowly lowering it without any acceleration. Think of it that way. All right? Then can you figure out what that force is going to be and what direction that force is going to be? Go ahead, give it a try. Pause the video and give that a try. All right, let's see. Let's consider when the barbell is somewhere in between, when it's still moving down, somewhere over here, let's say. Okay, now we know that gravity is pulling down on this barbell. So there is a force of gravity on it, which is mg, but this barbell is moving with a constant speed. It's slowly moving, no acceleration, let's say. Then the force on that barbell must be balanced, right? Because if the forces are not balanced, remember, the barbell would accelerate. And so to balance this force, she must push up on that barbell with exactly the same force. And so the force with which she's pushing on the barbell should exactly equal to the weight of that barbell, equals mg. Now, of course, one question you might ask is, if the two forces are exactly equal and balanced, why is the barbell moving? Why does the barbell just not stay at rest at the topmost point? That would be a pretty good question, okay? And here's how I like to think about it. Imagine that at the topmost point, her force becomes a little smaller than gravity, because of which the gravity starts winning and the barbell starts moving down. That's how the barbell starts moving. She momentarily, just for a fraction of a second, puts a smaller force. But then once the barbell is in motion, her force will match that of gravity, making sure the barbell moves slowly with a uniform speed. Okay? And if you think about it even more, then at the bottommost point, she needs to now stop that barbell, right? In order to stop that barbell, she now has to put a little larger force than the weight, again, momentarily. And so you see at the top, it's a little smaller, the bottom, it's a little larger, so they kind of compensate. And of course, in between, for most of the motion, the force is equal to that of the weight. And so we can say overall, her force should be equal to the weight of the barbell. And so if we go ahead and plug in, since we know the force, her force is equal to the weight for most of the motion, it's going to be mg times h. But one thing to be careful about, is it positive or negative work? Well, this time notice her push is upwards. Remember, it's this force that we are interested in because it's the work done by the woman. So her force is upwards and the displacement is downwards. And so they are in the opposite direction. Ooh, so the work done becomes negative. That's something to be careful about. All right, now we can just substitute the values of mg and h. 10 times 0.2 is 2. 2 times 20 is 40. And so our answer is going to be negative 40. Again, the units are going to be newtons, which is the unit of force, meter, Newton meter, which is the same thing as a joule. And that's our answer. So the work done by that woman on that barbell is going to be negative 40 joules. And so I guess the most important thing we saw over here is that whenever you are lowering or raising any, we can say that the force with which you're pushing on that object is pretty much equal to and opposite to the weight of that object, the gravitational force acting on that object.
You learned integration wrong.
Apaan
That's quite a
integral
claim.
apa?
So let me clarify what
Bukan
we
lagi
mean by
belajar
that.
anu
Our
bang.
claim is based on studies
Ya,
of former calculus students
trik
that analyze
interpretation
what
gua
students
lagi
think
ke level
integration
itulah.
means.
Gua
Students tend
lagi
to
mau,
conceptualize integration to have one of three meanings.
bukannya mau sih bang,
Integration is
udah
finding an area under a curve.
ke trik
Integration is finding an antiderivative of a
substitution
function.
sih.
And integration
Trigonometry
is
substitution
adding up a
integral.
tiny bit.
Today we'll be talking about
Nah,
trig
ini
substitutions. In particular,
trig
I'll give you guys
substitution.
4 examples on how to use the sign substitution. Of course, there are also the
1 per
tangent and
akar
secant
A square
substitutions.
kurangi
So the
X
first
square.
question is, when do we use
A
the
mungkin bisa
sign?
jadi 1,
Well, the answer for
X-nya
that
mungkin
is
bisa
when we
jadi
see a square, where a is
anu,
just a constant,
sin
minus x square, and if this
sin
right here is
theta,
itself the square
kok sin
root,
theta.
then it's usually a good idea
X-nya
to let
dengan
x is equal
A sin
to
theta sih
a
kayaknya.
times sine theta.
Ya
And
gitu-gitulah.
as a little note right here,
Kan A-nya
1
kan
minus sine
sisi
square theta
miringnya,
is equal to
X-nya itu
cosine
di
square
sisi
theta.
tegaknya
And I
jadinya
also want to
A
tell you
sin
guys
theta
that you could
menyesuaikan
have
di sisi
done this
miringnya
as
kan.
x is equal
Emang kayak
to
gitu
a
sih.
times cosine theta as well. But when you
Maka
differentiate
jika
that,
sin
the
theta
derivative cosine will give you
inverse-nya
negative
bukan
sign,
inverse sih.
and nobody likes the negative. So
Ya,
that's
A
why
sin
we will
theta
choose the sign for
kuadrat
this.
tambah
Take a
A
look at the
sin
first one. We have the
A cos
integral 1
theta
over
kuadrat
square root
sama
of
dengan
a
ya
square
A lah,
minus x square.
A
So
kuadrat.
as we can see, we have this right here.
Namanya kayak
And you
gitu.
see, we do not have x on the top because otherwise we can just do a use up for that, but we don't. So let's just go ahead and do this and see what happens. So I'm just going to let x equal
Plus I sin theta.
a times sine
Ya,
theta
betul.
as we set it over there.
Maka
And then we just have to
dx
do
sama
our usual
dengan
business. And the usual business
dx
is that
sama
we
dengan
differentiate both
d
sides. So we get
A
dx,
sin
and that's going to give us a, and the derivative of sine is
cos x
cosine,
cos
and then we have
theta
the theta
d
d theta.
theta. Ya betul.
So we can just now take this integral
ya guys,
to the theta
derivatif
world,
yang
and we're
hasilnya
looking
kan
at
cos x ya.
the integral of
Integral
1
of
over
1 over
square root,
roots.
and here we have the a square,
A
but this
square.
x right here is what we said to be a times sine theta.
A times
So we're
sin
just going to
theta
write that down.
minus
A
A
times
sin tan
sine
theta.
theta, and then we have to square that.
Square root. Ya sisinya
And we
anu
see
lah.
we have the dx
Cos
right here, which is
A
all
cos
that.
theta
So
lah
just be
sisinya.
sure that you multiply this right here as well. A times cosine theta d theta. Do not miss the
enak
d
tuh,
theta. That's
cancel-cancelan
extremely
anjing.
important. I will point out why later. So this is what we have now, and now we can simplify this a little bit. Here we have a square, and we also have x squared right here, so we can factor that out. A squared, and then we will just have 1 minus, here we have sine square theta. Well, this right here is what I told you. We'll be expecting to use this identity, so we can replace that with cosine square theta. So this is just a squared times cosine square theta. And you have to keep in mind, this right here is still inside of the square root right here, right? And the beauty of this is that this cancel out. So altogether, we just get a times cosine theta. And you don't have to worry about the absolute value for this indefinite integral because we're just trying to find an antiderivative for this. All right, and now here's the best part. And then we have a on the bottom, so we can cancel them out. Likewise, cosine, cosine.
Ya kan nak buat kan jadi cancel tuh.
So we actually just have to integrate 1. But the answer for this is not just x because we are in the theta world.
Ya, so, theta, hasilnya theta terus kita ganti substitusinya pakai inverse bisa lah. Inverse in x.
We have to go back to the x world, and to do so, we just have to look back here. We know x is equal to a times sine
theta. Ya, pakai segitiga itu kan kalau nggak salah.
So
metode segitiga terus ada sin cosnya segitiganya.
And right here we can just say theta is equal to the inverse sine,
x
over a. So ladies and gentlemen, this right here is just the theta, which is pretty much the answer for that. So I'm just going to write that down right here for you guys. Final answer, inverse sine of x over a, and then we are all done. So I'll just put the box right here and box the answer. Just like that. For number 2, we have the integral of square root of 2 minus x squared over x squared. Here we have this number 2. And we really have to look at that number as a number to the second power. So the truth is, for the 2, we just purposely look at this as square root of 2 and then square. So this tells us the a is square root of 2. So here you see we have that. So we can just go ahead and say x equal square root cosine theta d theta, and of course take this integral to the theta world. So we are looking at this as the square. I'm going to actually square root on the top, and I'm going to simplify this x, and we have to square that. And you can see if this is to the third, it's going to be that square root of 2 times sine theta, and then we square it. And don't forget that dx is all that, so we multiply by square root of 2 times cosine theta d theta. Wow. We see 2 minus, and this is just a 2, right? Because square root of 2 squared is just a 2. So we can factor that out.
Factor.
And then we get 1 minus, this is sine square theta. And this right here is again cosine square theta. And then we have the 2 in front, like this. And remember, this is still inside of the square root, like this. And the square root of 2 will just leave it as how it is. So we have square root of 2, and this right here, they cancel. So we just have cosine theta. So that's for that. And if you look at the bottom, here we have square root of 2 square, which is just a 2. And then this right here is sine square theta.
Yeah, sine square theta.
So this is what we have. Check this out. Square root of 2 times square root of 2 is a 2. That's on the top. But here we have another 2. So they actually all cancel each other out.
Cancel.
Alright? And then if you look at this times that is cosine square theta. I'm going to write that down to make it super clear. On the top we have cosine square theta. On the bottom we have sine square theta. And then d theta. And of course you can recognize this as cotangent square theta, and then you can use the identity to break it apart. But I would just like to prove that cosine square theta is the same as 1 minus sine square theta. So this is what we get. First we do 1 over that, and that will give us cosecant square theta. 1 over sine is cosecant, but this is the square, so we have the square. Next, this over that is just 1, right? So very nice. So we have that minus 1. Again, we are in the theta world like this. Now, what's the integral of cosecant square theta? Well, the answer for that is negative cotangent theta. And then minus 1. In the theta world, integrate that, we get theta right there. Okay, now we just have to go back to the x world, and this is how. Refer back to our substitution right here. I'll put this down right here. We know x is equal to square root of 2 times sine theta. We can just divide the square root of 2 on both sides. So we get sine theta is equal to x over square root of 2. Again, we are looking for the theta here. So theta is just going to be the inverse sine of x over square root of 2. So that's okay. Well, how do we get cotangent? This is how. So if you look at this right here, we can construct a right triangle. And I would recommend you guys to always put a right angle right here and the angle theta right here, just to be consistent. Because this way you can see x is the opposite, which is right here. And then